Hi Spring fans, welcome to another installment of Spring Tips. In this installment we're going to look at the Spring Boot Maven plugin, right? So we're going to build a new application here, just a demo, who cares, it doesn't really matter what the application is, just add in some web support I guess. And everything else we'll just leave alone, because we're not going to focus so much on Spring itself as we are going to on the plugin that we're going to use to build it. So let's open up our terminal, and then open up the application. Here we are. So that's going to open up the IDE. It's just a regular Maven build. I could have chosen Gradle, and the same things apply in the Gradle world, but I'll leave that to you as an exercise in documentation research to sort of see the analogs. All the things that we're going to talk about here apply equally, though. So we have a simple application, and again, it doesn't really matter. The application itself doesn't actually matter. We can create a REST controller, for example, and just say get mapping hi and string hi, return hello. There we are. So there's my basic Spring Boot application. We have a build here, right? This is a Spring Boot application. It's a jar application, a so-called fat jar, and the fat jar has the Spring Boot Maven plugin. And to understand and appreciate what this Maven plugin does, we should remove it first, right? So go here and cd downloads demo Maven clean install, or package even, doesn't matter. And we get compiled code, go to the target directory. There we are. If we look at the demo jar, it's 12 kilobytes, but I can't run it, right? It doesn't have a meta-inf directory, and it doesn't have a manifest file inside that meta-inf directory. That manifest will tell the JVM what class to run, what is the main class, the class that has the public static void main method. With that information, the JVM can then run the code and start our application. Without that, it's just a jar full of code that could be loaded in as a library into some other JVM process, but that does not in of itself constitute a runnable jar. You could run this if you specify a main class manually as well, right? That's an option. But you'd also have to specify the class path. Now the class path is nowhere to be found. I mean, this whole target directory is 216 kilobytes, but of course, I've got Tomcat, I've got Spring Boot Starter Web, which brings in Tomcat, which we know is at least 10 megabytes, right? So that's clearly not everything I need to run the code. I can copy the dependencies here. I can use the Maven dependencies plugin, Maven dependencies, copy dependencies, and is that right? Let's see, Maven dependency, is it that? No, it's dependencies. Oh, no wonder, none of it's working. Wrong folder, let's see. There we are, let's try that. There we go. So it was Maven dependency copy dependencies, and you can see that that has copied all these different dependencies that I need for the application into the target directory /cd target / and then there's a dependency directory, and there you can see all the jars required to run this application, everything that's inside of it, or everything that's required to make this application work, right? So if I look at this directory itself, it is 18 megabytes. There's our entire thing, right? And it includes the web support and Spring and logging and all that other stuff, right? Well, Hibernate validator, yeah. So all that is there. Okay, so we have now a trivial application. If we wanted to run it, we'd have to specify class path ourselves manually, Java -cp, and then list all the classes that, or rather, list all the jars in the dependency directory, and then give it the main class to run. So we're clearly far away from useful. That's why this Maven plugin is so valuable. This plugin, first of all, it creates a meta-inf directory and a manifest, and it tells Spring where to find the runnable code. But it actually does a fair bit more than that. You see, it actually embeds all the other jars inside of the archive that gets built. That's why if I run this code again, Maven clean package, there we go. There we are, cd target I have here another jar, and this jar is 14 megs, right? So that's the compressed version of all the libraries that we looked at before. This jar is one self-contained thing, right? It needs only a JVM, a JRE actually, not even a JVM. It needs a JRE, and that's it. I mean, the jar itself is self-contained, so I can do java minus jar demo snapshot jar, and that works because of the way that the plugin configures everything. Let's take a look at the structure of the jar to see what I mean. So demo, okay. Actually, I should have. Let me see if I not to this, and we'll keep everything except for. We'll delete everything except for that. There we are. Now we have here jar xvf demo. There we are. So now, if we look at the directory output here, you can see that the contents of the jar included bootinf, metainf, and org. Ignore this jar, of course, because that's the original jar itself. Org. If we look at the tree here, org is the org are org, Spring Framework, bootloader, archive. These are actual Java classes that get put at the root of our jar, just like our normal compiled code would be had we not had the Spring Boot Maven plugin. So this is the code that the JVM is going to actually run, right? And this is in the right position. It's in the right place for the JVM to find it and load it normally. And this code actually provides its own sort of class path. It provides its own class loader and its own idea of a jar file. You can see here we have actually classes called jar file. This jar file class extends from the java.util.jar.jar file class. It is a drop-in replacement for that jar class, which is nice, by the way, because it means that tooling can use this mechanism if they want, and it'll still work, right? But all this to say, this code describes a custom class loader and a custom scheme for working with jars, and that scheme supports nested jars. You see here that we have in the bootinf directory, we have the classes of our actual application itself, the code that we wrote, my little REST controller with hi, and then the class path that supports that. So this is the stuff that we'd have if we didn't, if we weren't using the Maven plugin. This stuff would be at the root. This lib directory, on the other hand, wouldn't be there, right? This lib directory is all the class path. It's the stuff that we saw in the dependency directory earlier when I ran that Maven dependency copy dependencies command. This is the class path required to support the application. This is the application itself, and this, and back in the org directory, this describes a hierarchy of code designed to support loading and resolving and running the application within the bootinf directory. So it's a fairly different scheme than what you may be used to. You may have seen other things that attempt to get you the same effect, right? There's the Uber plugin and the Shade plugin, Uber jar plugin and the Shade plugin. These are different Maven plugins out there that attempt to give you self-contained jars, and they're all very interesting. But most of them we have found they try and explode the jars into one global namespace, and that you quickly run into a situation where you have conflicts, right? The jars themselves, the contents of the jars are exploded into a global namespace, and then so you get conflicts, and you need to reconcile those conflicts, and that gets tedious, right? You have things like the metainf directory, where of course every jar is going to have one of those, and some contents in there, or at least they could, and you have to reconcile. You have to reconcile the difference there, so that gets tedious very quickly. And so we found that it wasn't so hard to support doing it this way, to actually support resolution of code within a jar as we are here, and that's what that whole custom scheme does. The only limitation to our custom scheme here is that if you're writing code that uses the system class loader, that's not going to work the way you expect it to work. Instead, you should be using the context class loader, right? So if you are writing code that uses the class loader and you know about the class loader, then you'll know what that means. If you don't, then great, you're probably fine, right? You're not going to need to worry about it. Most libraries, most frameworks use the context class loader anyway, so this is not a problem that you're going to run into, except in very exceptional circumstances. But other than that, this will work, right? This is actually a self-contained jar. This jar is not something you want to put on the class path of other jars, though, of other applications. By building it in this way, you make it harder for the JVM to load it as a library. It doesn't work the way you'd expect, but that's fine. We're trying to build an application, not a self-contained library. So we have everything within the application, and that's fine. The application is now, like I said, we can do java-jar demo.snapshot-jar. We can override properties. For example, the port, I could say export server port. Let's see, export server underscore port equals 8020, and then do java-jar demo, and the application now spins up on port 8020, right? So you can see that we're able to change the default behavior. I could have a property file here. I could say echo server port equals 8010 application.properties, and then just in the same directory, I'm gonna open this up again, close this one, and open that one up. And you can see here I've got cat application.properties, and I've got the jar, so java-jar demo.jar. And I said I wanted to run on port 8010 in that property file, and there we are. So I'm able to change the default behavior of the application. I'm able to build the self-contained application. All I need to do is manage starting and stopping and restarting and statusing the application. I need to tail the logs and so on. So one of the common reasons that people use application servers, like Tomcat, right, which is the most ubiquitous by far application server in the Java community and ecosystem, one of the reasons that people use that is because they want to have the lifecycle management, right? The lifecycle of the application itself, the start, the stop, the log, following, etc. So you have to reinvent that in this case, right? So far we don't have most of that capability, and additionally, there's no easy way to manage this. You have to do the admittedly not so painful but still tedious work of installing this as a service in your operating system. If you're running this in a production environment, it's more than likely going to be some sort of Unix flavor, so a Linux, and so you're going to want to install this as a service so that it gets run when the application, when the environment starts up, and it's going to be destroyed when the environment is itself destroyed. So all of that is kind of left as an exercise for the reader, unless you're using an application server. That said, we're not using an application server. We have the embedded web server, so we need to solve that problem ourselves, and that's easy to do with the Spring Boot configuration here. So there's a lot of configuration options here for the Spring Boot Maven plugin. Right? You can specify things like what Java agents you want to run, which custom classes directory you want to run, what artifacts you want to include or exclude. Do you want to specify JMX specify JMX properties? Lots of different things you can do here in the Maven plugin for the Spring Boot plugin. But for what we care about is whether the jar is executable or not. So we're going to make it executable equals true. By default, it's a executable jar, but that's not quite the same thing as what we're talking about here. It's what we're building now is a new kind of executable jar. So Maven clean package. All right, CD target. Now, same thing as before, basically, 14 megs. But this is different, right? So less. So what I just did is I did less demo001 snapshot jar, and I'm greeted with a shell script. And the shell script is actually the first. It's the header. It's the first part of the jar archive, and the header. The shell script does a lot of things for you. It actually does a lot of stuff for you. It installs a PID directory. It installs a folder to store a PID file where you can see the status of the application. It creates a folder. It manages logs. It manages permissions for the application itself. It gives you functions that you can use to see if the application is running. You can say is running, for example. You can there's a lot of support here. I don't expect you to read all of this yourself, but suffice it to say, there's a lot of functionality here for starting and stopping and statusing and force stopping and force reloading and running the application. You can see all that here as commands, right? So these commands are all supported and they're very useful. And the reason they're useful is because you can use these in conjunction with initd or system V style initialization. So the script is meant, the script is actually run before the JVM runs the jar. What the script does is it actually loads the jar itself, right? The script gets run by the operating system. It then loads itself. It reads its own file and loads the jar. And the jar, of course, is the binary data that you see here. This gobbledygook on my screen is all the contents of the jar, kind of encoded in that shell script. And to understand how that works, you have to consider how the operating system reads files, right? The operating system reads a program into memory starting from the top and going to the EOF, the end of file marker, right? And that's just sort of how most Unix operating systems work. The JVM, contrary to the operating system, reads its archives and applications in reverse. It reads from the end of the archive until the beginning of file marker. Well, of course, there's no reason that those two things have to agree. There's no reason that the beginning of the file for the operating system has to line up with the beginning of the archive for the JVM. In fact, you can do some very interesting things if you keep those things separate. That's what we're doing here. Our shell script has an end of file marker, which the operating system then reads, and the shell script then reads itself and gives it, it gives its own contents to the JVM, and it does so by reading from the end of the shell script, which is the jar, to the beginning of the file marker, which is, of course, right after the shell script. It's the first byte right after the shell script. It's there's a discrepancy there, but that works. Now, the benefit of this is, of course, I can do this demo. Right? I didn't have to say java -jar. I just executed the program like an executable shell script on my operating system. I still need a JVM, mind you, but I have that ability already, and I can now use this within initd and systemd. So initd, Spring Boot, Maven, plugin. Okay, so you say executable equals true. Here's a equivalent Gradle configuration, and you can now use this with initd or systemd right here. So there you go, sudo lns myapp.jar and etc. initd myapp, and then once that's done, you can say service myapp start, for example. So you get the ability to manage the application as a service on the operating system, just like MySQL or any other thing that you're running as a daemon in the background. And of course, you have logs written to var log app name, and there's actually a PID that gets managed for you by the operating system, by the script itself as well. And you can tell the operating system to start it automatically using update rcd myapp default priority, etc. Right? So lots of things you can do here. You can also look at the documentation for information on how to secure it, right? So that it runs in a secure, protected process and with protected permissions. A lot of options, right? So I encourage you to peruse that at your own leisure. One thing I want to really, make sure you understand is that you can change everything, right? Including the shell script itself. You can provide your own custom shell script, and you can even copy ours and just change it a little bit. You can provide a custom shell script here, and provide your own embedded launch script, and that launch script can do whatever you want. Now, maybe you want to override just the properties that are used inside of our launch script. That's fine as well. You can do that here. So a lot of options. I encourage you to peruse that to sort of explore that later on. But for our purposes, I think that's a good enough introduction. The nice thing about this jar is that it's self-contained. Right? As I say, it's a self-contained demo application, and we have got one endpoint here. We have one REST controller. We have 3 lines of code, and that 3 lines of code required 18 megabytes in space. Might seem a little disproportionate, but you do get benefits, as we've just seen. You get operational benefits from having to co-locate all the libraries in the application archive, the binary itself. That said, things could be more compact. I agree. They could be a little bit more svelte, a little bit more convenient. This is only a problem if you start archiving these binaries in something like your Nexus repository or Artifactory. There, you might not want to store 18 megabytes every single time, right? And this is just a trivial application. I haven't even begun to add anything else to it. So in this case, you might enjoy the fact that you can use the Thin Launcher. Now, the Thin Launcher is a custom Maven, it's a custom Spring Boot Maven plugin layout. Layout is an extension plane for the Spring Boot Maven plugin that you can override, and there's a few default layouts. There's jar, there's .war, and then there's a new one that the good Dr. Sire, who's the co-founder of both Spring Boot and Spring Cloud, has created. And this is called the Spring Boot Thin Launcher. It's not officially part of Spring Boot itself, but it's very, very useful already. And you can find the code here, dsire Spring Boot Thin Launcher. The code is fairly simple to get going. So here we're gonna override the Spring Boot plugin here. We're gonna add this bit here to our Spring Boot plugin. Okay, whoops, don't need this, and don't need that, and we need the version. It's 1.06, I think. Yeah, 1.06 release. So there we are. There's a custom version and our custom Maven plugin with its own custom Spring Boot thin layout. Right, the thin layout has everything we need to run the application. But what the Thin Boot layout does is it installs in the binary the ability to resolve its own class path using Maven, using the same Maven dependency management mechanism. So here, Maven clean package. cd target do-hs demo. Oops, what did I do there? Do-js. Okay, 20 kilobytes, right? So it's a little larger than we saw in the very first time when we had no plugin at all, but it's still trivially small. And if we run this application, everything will still work. So java-jar demo snapshot jar. There we are. You can see it's the application spun up as quickly as we'd expect, except that it's resolving its class path dynamically. If right now it's looking in the local M2, my local M2 repository directory, and it's finding all the libraries that are in that repository directory, and it's loading those as it needs to dynamically. I can tell it to load those dependencies in a separate class path. I can say java minus thin dot root, is it, I think, and it'll just be lib we're going to say java minus star thin dot I think it's thin dot root. Let's see, there it is, cd lib. You can see that when I said thin.root equals lib, it created a directory called lib. There in the repository directory, we see that it has created a class path. It has created a Maven repository, basically, that has all the artifacts needed to run this application. So it used the Maven dependency resolution mechanism when it started up the application, and it resolved all the dependencies and put it in that jar. Now, of course, if I run the same command again, with that same exact invocation, it won't need to re-resolve them, right? They're cached, right? That's what happened the very first time. It ran that command relative to the local M2 repository directory, and then it just worked, right? So here I'm saying thin.root equals lib, java minus jar, demo dot whatever, cd target. Okay. So again, it doesn't have to resolve anything. Now, consider an operating system where you have no dependencies on the class path. You have nothing on the local machine, nothing on local M2, nothing anywhere, right? Then you would need to have internet connection, right? So you'd need to download it, right? Obviously, this is not going to work without its dependencies. So that adds to the startup time. Hopefully, you've got fast download capabilities. No doubt you do in a production data center. But that's a cost that you have to be prepared to pay. So you can either have it pre-cached. You can actually stage your usage of the libraries, the dependencies. You can actually run a pre-flight, if you will, in which case you can get all the libraries downloaded and then cache them as you would, right, for example, here. So java -d thin.root equals jar, or equals here, and then like that. This will download everything to that directory. You could do a dry run by specifying a property here, thin.dryrun equals true, and that will actually download the dependencies for you and not start the code, so that you get the best of both worlds. You can download everything and then start the application, guaranteeing that it's going to work when you do start it, right? And the benefit of that is that, of course, you can have all the dependencies you need to run the application, but you don't have to store the built application with all the dependencies included in the artifact or Nexus repository. You can have it only in the container itself that needs it, right? Or you could just do everything sort of dynamically. You could choose the thinnest, smallest container that you need for your operating system, and then just deploy the tiny thin jar and let it download the dependency, the class path that you need for that application. That will work just fine as long as your platform, whatever technology you're using for cloud computing, doesn't have a requirement for timeouts, right? Hopefully you don't need too long to download all those dependencies. If you can do it within that timeout, then great. As it happens, this trivial Spring Boot application that I've just built here is small enough and quick enough that it will download and work just fine on something like Cloud Foundry, right? So if I were to push the application here with it, as you can see here, cf push my app -p target demo jar, and then specify a build pack, this will actually stage the jars before the application tries to start up. So it inserts itself in a phase in the Cloud Foundry lifecycle, in the Cloud Foundry app lifecycle, before the application starts up. It downloads all the jars, and then it does java -jar, and so you're not counting against that timeout. But even if I were just to do cf push my app, specifying this jar and ignoring the build pack, for this trivial application, that would absolutely work, right? It's small enough that I could get that done in the time before the timeout applies, right? So you can either use a custom build pack to get around that, or you can just, if it's small enough, it'll just fit. And you may not even have that problem. Who knows? I mean, the point is, this is a good option, and there's very few cases where it's going to be a problem. The only places I can think of where you might have problems is if you're running against a timeout when you start up, right? Because it's going to have to do all this when the program gets run, when it starts up. So keep that in mind. I like the thin approach. I think it's like the best of both worlds. You can do interesting things too, because remember, the class path is being provided external to the application. If you wanted to, you can actually provide a thin.properties file that then contains its own dependency manifest, right? That's actually what's happening here. If you look at this jar, let me see, open this again, and I will grab only that, delete that, and we'll say unzip. There you go. So if you look at the directory here, you can see the directory contains the metainf code. It contains a thin jar wrapper class, which in turn is delegating to this demo application and to your Maven POM. It's using the Maven POM that's in the archive to resolve the dependencies. But you can provide those dependencies in a custom format as well. You can provide your own custom property file. So thin.properties, right? So here it says dependencies Spring Boot Starter Web equals org Spring Framework Boot Spring Boot Starter Web, right? So here's how you would externalize custom dependencies, and you could use that as the class path. You could overwrite the class path that the application has inside of it. So if you want to upgrade Spring Boot and Spring Cloud, but nothing else, you want to change the dependency version, for example, you could do that by overwriting the bombs section in thin.property. So here you'd say BOMS, that's the Spring Boot Maven bombs, the bill of material dependencies, bombs.springboot dependencies equals org Spring Framework Boot Spring Boot dependencies 1.5.6 release. So here you would be forcibly upgrading the awareness of a particular dependency to 1.5.6. Everything that uses the Spring Boot bomb, which in the Spring Boot application is everything, would now be pinned to 1.5.6. You don't have to recompile the code. Now, do I recommend doing this in production code? No, of course not. I mean, you should definitely absolutely go through the regression test and auditing and all that stuff, but it can be very convenient in a pinch if you need to do that. We try our best to keep things sane so that they work backwards and forwards compatibly. Obviously I wouldn't want to try this with a giant 1.56 to 3.0 bump or something like that, but you'd be better off if you knew about that, if you had a security vulnerability that you need to get patched right now, or something like that, right? That's just a convenience. So you have a lot of options here, right? A lot of options to run your Spring Boot application. And again, I've talked about servlet container options, right? In a previous Spring tip. So that's not what we're talking about here. We're talking about the Spring Boot Maven plugin and a number of different strategies for running them. Also of note is that the so-called fat jar thing that I showed you earlier, that can be used with a .war, the first approach that we showed you with the Maven plugin without it being executable. You can use that with a .war as well. That actually gets you the best of both worlds. You can deploy that into a servlet container environment and also do java-jar my.war, right? And that actually gets you something that works in both environments. So a lot of options here, a lot of flexibility. Now, one thing that isn't there yet that I'd love to see, especially in light of JRE 9, Java 9, is the ability to have, for the shell script that we saw earlier, to download a JDK, a modern JDK. And Java 9, I think, is a perfect vehicle for that. It provides modularity, and that modularity applies mostly to the JVM itself. You can decompose the JVM into smaller modules that you can then repackage in whatever arrangement you want. And so you could, for example, build a JRE that doesn't have the code for Corba. Well, good, we weren't planning on using that anyway in our application, so we could cut that out. You could have a custom redistributable JRE, and I think Oracle even signaled that they expect applications to ship the JVM with their they expect Java 9, the Java 9 JRE to be shipped with your application, so as to make it easier for developers to get a consistent experience, right? Especially now that they're going to be releasing lots of new JVMs every what is it, 6 months, something like that. They're going to have a new scheme where it's twice a year, something like that. So it could be very valuable to pin your application to a particular JVM as opposed to relying on whatever resident JVM is on the operating system. So we'll see, and I think that would be an interesting extension. You could do that, of course. You could already, since you can control the launch script, you can provide your own JRE resolution mechanism. You could actually download your own, as opposed to the Java, Java command detection logic that's in the launch script right now. So, okay. So with that, we've looked at the default behavior of Spring Boot and the Maven plugin without the Maven plugin. We've get to a jar. We looked at how you could resolve the class path if you didn't have that plugin. We looked at the Spring Boot Maven plugin and saw what the default behavior gets you. We looked at some of the configuration options and saw that you can change a good deal of things about the resulting fat jar using the Maven plugin. We also looked at the executable option, right, and the executable launch script that you get in Unix operating systems, and how that allows you to run the application in systemd and initd style environments. And then we finally looked at the one of many possible layouts. This one is called the thin layout that applies to the Spring Boot Maven plugin. This is a project from Dave Sire, Dr. Dave Sire, one of the Spring team members. And we then talked about some of the issues you may have if you use this approach, and some of the virtues you may have if you use this approach. So with that, thanks so much for watching, and we'll see you next time.